My name is Jens Christian Refsgaard, and I'm professor in water resources at the Geological Survey of Denmark and Greenland. And I'm going to tell you about what I love very much, namely water. I will be addressing these 4 questions which you can see on the slides here. First, about do we have enough water on planet Earth? Second, what will climate change be and how will it affect the condition for water and our conditions for life, for civilization? And the last one, can we do something to prevent the problems which are going to come? I've been using a lot of literature on this. You don't need to link it, but just this is the most important part of it. But let's go to water. As you all know, water is very important. Without water, no life, no civilization. We drink it, we take shower in it, as you saw before. We use it for cooking. Plant use it for growth. So without water, no plant grows, no food. It's a basic thing of ecosystems, and it's also affecting climate very much. So water is fundamental for human civilization. And therefore we can ask, are we running out of water? Some places there are problems. This is from California, which is a semi-dry arid, where a lot of people have moved. And they have droughts once in a while. This is exemplified by the figure here where you can see a reservoir with a lot of water in 2011 and almost no water last year. Water is essential for agricultural production in California, but without water, no food production. And my wife just told me that last year the almonds we got from California were much smaller this year than they used to be because they're lacking water. So it's very important. What are you doing then if there's lack of water? Can we fight it? It's very difficult to fight drought. So human beings has since the start of civilization instead turned to the higher powers and prayed for rain. Maybe that helps. If not, you have to adapt. And if you are sufficiently innovative, you can find new businesses. Do you know what that man is doing? Yes. He's painting a lawn with green watercolors. Let's go to another place on Earth. North China Plain. A place around Beijing and south of Beijing, down to the Yellow River here. There are around 130 million people living in an area a little bit more than 3 times that of Denmark. There's been a tremendous growth in industry over the past 3 decades. Industry in China takes up a lot of water. It's also an area where it's a breadbasket of China. Agriculture there is dependent on agriculture and gross food production has been rising. So they've been pumping a lot of water from groundwater. And what happens then? It looks like this. This is what we call depth to groundwater. By that we mean that if you dig a hole in the ground, maybe put a well in it, back in the 60s, you would need to go down 6-8 meters or so. Then you would find water. Today, you have to go down around 50 meters. And it's continuing like that. Obviously, this cannot go on forever, because after some time, there's no more water. So they're using more water than is renewable coming in by rain. So that's a serious problem. What are the Chinese doing to that? They are doing the traditional things we've always been doing, turning to engineering solutions. California did the same in 1928 when they diverted water from Colorado River, which now has much less water than it used to be, but still Colorado has problems. China has constructed, almost finished by constructing, the world's largest diversion scheme for water, transferring water over thousands of kilometers from south, where there's more water, to north, where they're lacking water. How long time do you think this will help the problem if they continue with the same growth rate of water use in China? Five years, somebody say. Somewhere between 5 and 10 years. Then this amount of water corresponds to the growth in 5 to 10 years. So that's not a sustainable way either. It helps a little bit, but not forever. In this map, you can see an indicator, a water scarcity, a water stress indicator. It shows by colors, maybe here, just look at the colors. We were in China before, we were in California, that's a dark. The darker the color is, the more the exploitation of water is. And you can see that there are some areas in America, around northern part of Africa, around the Mediterranean, Middle East, Central Asia, parts of China, most of India, etc., is water scarce. Altogether, a little bit more than 2 billion people are living in these areas today. Now, what are we then using this water for? Here you can see the development of use of water since 1900 up till today, and we'll a little bit forecast 10 years into the future. With blue color at the bottom, you can see that's the water which goes, we call it drinking water. That's for household. That's what you can get in your taps. Tapped water. The red one, that's for industry, a little bit less. And the major water consumer, that's the green one. On top, that's for agriculture. And most of that is for irrigation. So that's essential for our food production. But it's a very rapid growth. It continues. And then you can ask, does it have to continue like that forever? Here we can see on the next slide, situation in Denmark. I don't have numbers back to 1900, but from 1900 up to 1970, we would also have seen a growth like on the previous figure. But otherwise, this figure is very different in the sense that the maximum water use in Denmark was in 1980s, 30 years ago. Today, we're only using a little bit more than half of that. And the major places where reduction has taken place is in households, our domestic use, for drinking water, and in industry. And the reason for that is some measures, we could call them water management measures. First of all, the price of water, as some of you who have my age would know, has increased dramatically from 5-10 kroner per cubic meter up to more than 50 kroner per cubic meter. And that has given some incentives to save a little bit of water here and there. Secondly, there's been very large campaigns from the water companies to save water. That's also helped. So it's a company who are selling water who also ask people not to buy so much. That's unique also, because we have the owner structure we have for the water sector in Denmark. And then maybe last also, there are restrictions on how much water agriculture are allowed to use. You need permissions to irrigate, and that's restricted as well. So it is possible to break that curve. And I don't think we have a more poor life and we have less shower than we had 50 years ago. So what do you think you use your water for? Now, you have 3 options here, and I will ask you to think about that and raise your hand. One option is if you eat a beefsteak, 250 gram. Second, if you drink 12 beers. Or thirdly, if you take daily baths, as I did here, for 3 months. What's costing most water? Who's voting for the beef? Somebody voting for the beer? Somebody for the bath? Yeah, some for the bath. Thank you. So you're very well educated. It is, of course, the beef. 20 beers would not be enough either. But why is that? I mean, it's not because the beef in itself contains so much water. I mean, but it's a life cycle analysis where you say to produce this meat, the cattle has to get some food from grass, from maize, and that requires a lot of water. That's what we call virtual water. And you can Google it and you can find out what's consuming your water. Here's a table where I show 3 items for something you can drink, 3 for something you can eat, and for 3 other commodities. So if you take 1 glass of beer, it takes you 75 liters of water to produce that. If you go for coffee, prefer coffee, 140 liters. And for milk, 200 liters. So if you would like to save water, you better drink some beer. So. Or maybe drink a little water. That'll be cheaper. Good. Now, just to sum up the first part of it, do we have enough water on Earth? If we make a global average, we could say yes, there is enough water altogether on the globe. But the water is not well distributed, and people are not well distributed around the globe either. So there are some places where there are water scarcity, and those places water management is very crucial. That's today. What about the future then? Here we are facing some problems, or some challenges, we should say. One is that the amount of people is increasing still for the next 50 years or so, maybe. And that will generate a growth in water use. We're also polluting a little bit more of the water we have. That's the same type of problems we're dealing with today. So I think that if with some political will and good management, we would be able to cope with that. It's a little bit more, of course, than in the future. But we're getting a new player in, one which is changing the water game, and that's climate change. And that will fundamentally alter the conditions for many things with relation to water. And that's what I'm going to address in the next 15 minutes or so. Do you know this curve? I think you should consider that as one of the most scary curves in your life. That's the concentration of carbon dioxide, CO2, in the atmosphere, and the development of that from 1960, where it's been growing steadily with some annual fluctuations up till today, and it still continues to grow. I suppose you all know why it's scary. It's because it's one of the greenhouse gases, and it has the effect, like glasses in a greenhouse, it's going to form part of the greenhouse gases here, that it allows radiation from the sun, shortwave radiations, to enter. But when the ground is re-radiating long-wave radiation, some of that is being stopped either by the glasses here or by the greenhouse gases. So it's trapping water and it's contributing to global warming. Global warming is something which is here. It's not just something which is coming. This is a map from the recent report from UN Intergovernmental Council of Climate Change, IPCC, which shows measured values of increase in surface temperature over the past 100 years or so. There's some wide areas, that's where there are no data. But otherwise, in some places it's more than 1 degree increase. There's a small area in the North Atlantic where we see some decrease in temperature. All the other places increase. And the global average of this is around 0.8 degree of increase. Now, we can see that was temperature, but we can also see it on other variables like precipitation, and precipitation is rainfall and snowfall. That's also increased. Some places, this is the map, what happened since 1950. You can see some blue areas here. That's where it's increasing. We are in one of those areas where it's more rainy than it was when I was a child. There's some areas where it's decreasing. But the point is that it's changing. So some places get wetter, others get drier. So it's not stable. What's going to happen in the future then? That depends on the global community and how we behave, how much fossil fuels we are burning. IPCC has developed 4 scenarios of what they call concentration paths of carbon dioxide. Those 4 you can see in this small picture here of how it'll behave to 2100. There's the blue one here, they call it 2.6. Don't notice too much about that, but that's the blue one. The low one, that's what they call a stabilization scenario. That's one which is we have to stay on if we want to keep within 2 degrees warming. To do that, we are allowed then to have this emission of fossil fuels in terms of petagrams of carbon. We are around here now. So it means, as you can see, that we have to break this curve within the next 5-10 years and to reduce the emissions. And it has to go down to basically net zero by the end of the century here. If we stay on with business as usual, we'll be on this curve here. So depending on our behavior, decisions taken at COP21 and further on, we'll get different climates. And here you can see what happens to, many of you have seen these curves before, I'm sure, what happens to our temperature and what happens to our sea level. And you can see the temperature is going to increase. In any case, this is the stabilization scenario, where you'll end up with, there's a middle line here, which is the best estimate, and then there's some shaded area, which is the uncertainties. Our models are not perfect. So therefore, we also indicate the uncertainties in these projections here. For the business as usual scenario, we'll end up with somewhere between 3 degrees and 5.5 degrees increase by the end of the century. Sea level will continue. Well, this is how it looks this century in the period where you'll be living. But hopefully the world does not stop there. It'll continue. So in the era of your grandchildren and grand-grandchildren, it will look something like this, very much depending on how we behave. But the only message I would like to give here is that it's not stopping in 2100, and especially if you're on the high-end scenarios, it'll really increase both the temperature and also the sea level. And sea level will, when we pass 2100, we do not speak about tens of centimeters, but we speak about meters then. So we will have increase, we will have climate change. We don't know how much. It depends on global political decisions. Each of us can hope the best. That will affect water. It'll affect the whole circulation of water. It'll affect the availability, scarcity of water. It'll affect the floods and droughts, tropical storms, food production, and in the last end, the living conditions, the socio-economic conditions of our societies. So let's take a look at a few of those. This is, of course, my favorite figure because that shows the hydrological cycle. That's back in our science. So what happens is that water is evaporating from surfaces, from land surfaces, from water surfaces up into the atmosphere. It's forming clouds. Cloud is moving around, and sometimes it goes down as precipitation, as rainfall or snowfall into the head of us and into the land surface. And it's going into the soils, and that's penetrating and filtering out into the ocean. So that's the circulation. And the engine in that is the energy coming from the sun and the energy being contained on the earth. And that's going to be changed. And as we change the energy cycle, we'll also change the water cycle. So all of these water cycles, the magnitude of those will change every places on earth. This is some projections showing what will happen to our rainfall, precipitation, by the end of the century here for the high-end scenario. And you can see with blue, some areas will get more rainfall, some will get less. You can see on the other one, that's the runoff, that's the water in the rivers. The water in the rivers, you can say, is a measure of the total availability of water, the maximum limit of water which we can hope to make use of, if we can stop it from running out into the ocean, but that's another issue. And that's also, you can see, quite radical changes. Northern Russia, Canada, 20 to 40% increase. Other places, Mediterranean will be very, very dry. Western America will be very, very dry as well. So, how will that change in water system, rainfall, runoff? How will that affect our water scarcity? You saw this figure before. There are two things which will affect it. One is population growth, and the other is the climate. And if we first look at the population growth, you can say that the water scarcity here is, we define that here as if you have, as an indicator saying that areas where you use more than 40% of the water which is renewable. We show this region is a water scarcity region. Does not mean that it's running out of water, but we're getting in trouble there. So we have to be very careful there. So that's today, that was these 40% of the population, 2.5 billion people. That will increase up to around 4 million. That's in the scenario without climate change. That's just due to population growth. Population is here assumed to stabilize around 2050. So it's around 45, 47% of the world population. If we then add climate change on top of that, we get some numbers which are a bit more complicated. So what happens, for instance, here at 2050 is that 1.2 billion people who otherwise would not be in water-stressed area will now, because it's raining less, come in a water-stressed area. On the other hand, another 1.2 billion people living in other parts of the area will move from previously being in water stress to now being out of water stress. This is part of China, for instance, which is, in these projections, are assumed to have higher rainfall, and which previously was in water-stressed area. So maybe North China Plain will be saved by rainfall, but other places will suffer. So the key message in this is that in addition to the increase in water scarcity due to population growth, we'll have a reshuffling of areas due to climate change. Some places will be worse off, some will be better off in a relatively few period, maybe one generation or so. And that may alter living condition, which may motivate some people to move to places where the grass is greener without having to paint it. So we'll get more extreme events, we'll get more frequent and worse droughts, we'll get more floods than before, we'll get also some worse tropical storms. If you recall Katrina, some of you, the tropical storm which destroyed New Orleans 10 years ago, or Sandy, which hits New York a couple of years later. Calculations by scientists from the Sport Institute has estimated that the frequency of these storms will increase by a factor somewhere between 2 and 7 for each extra degree of warming. So if we say 4 degrees of extra warming by 2100, 2 to the power of 4, 7 to the power of 4, we will maybe experience, or New Orleans will experience Katrina once per year or something like that. That's not going to be very fun. What about food then? Food is very important. Without food, we cannot live. This is a very complicated figure, maybe a little bit busy, from IPCC. They've compiled results from more than 1,000 projections of what happens in terms, are we getting better or more increasing crop yield, plant production, or decreasing crop yield? It's from different countries, and it's from different climate projections, some mild projections, some very warm projections. So what it, for instance, shows is that, is if you look at the period from 2030 to 2049, it shows that 30% are with blue. Blue indicates and is an increase. In 30% of the cases here, there will be an increase of plant production. And that can be countries like Russia, Canada, Northern Europe, which are well placed with regard to taking benefit of climate change, at least in the beginning, while in 70% of the cases we'll have a decrease in crop production. That'll be in the warmer countries, tropical countries, Asian countries. You can also see the severity of this. 5% of this increase will be more than 25%, while 10% or so of the decrease will be more than 25%. If you look at the trend over the century, we can see that as we go from now towards the end of the century and it becomes warmer, crop yield will have a tendency to decrease. At the same time, there'll be more people on Earth. So that's not a very favorable condition. So this cocktail of scarcity, extreme events, problems with food security, will that generate some climate refugees? On this cartoon, you see people coming from some of the islands which have been submerged by sea level rise, and they come to the office and come to the UN, and the international community tell them something like, sorry guys, we cannot recognize you as climate refugees because we have no international convention with that name. But irrespective of that, it is a growing concern in the international community, also discussed at meetings at UN level, that this degradation of living conditions, which is a consequence of climate change and where water plays an important role, that this will lead to instability, social instability, political instability, which will affect all of us. I mean, when we think about how difficult we have in handling just a few 100,000 refugees from Syria, from a war, I mean, this, I'm not saying it's going to happen, but if it happens, it could be at a much larger scale than those just few 100,000 people. So can we prevent the problems? Or can we adapt to it? Let me first try to, what happens here? Okay, answer two questions in relation to to this. First, when is it too late? And secondly, can we reverse it? And if we talk about the timing, we noted that climate change is already ongoing. We also saw this, you saw this figure before. Saw this figure before that you have to keep within the 2 degrees. We have to take very radical and very swift actions within the next time. We maybe have it theoretically 10 years to prevent it from happening. So COP21 has to come up with very important decisions, more than is on the table now. So, but what happens then if we are not able to make it these 10 years? If we're just exceeding it with 10 or 20 years extra release of CO2, can we then just not wait another 20 years and then come back to our normal, nice situation? And that's unfortunately a bit difficult, because when CO2 is out in the atmosphere, it takes a very long time for it to disappear. You can see 2 curves here, one with a small emission, which is maybe equivalent to some years of emission, and a big one. And after 10 years, 20 years, 50% of it is still there. After 100 years, 30% of it is still there. Because it takes a long time for it to be taken up by plants or by sea or otherwise. So it takes centuries. And in the meantime, some of the ecosystems will have disappeared, and maybe there will have been some irreversible damages also to some of our societal systems. So the impacts of water, which we are going to see in terms of floods, droughts, food security, etc., will lead to fundamental changes in living conditions. But we'll also see very uneven distributions. There will be some countries which at least the first 50 years will benefit from it, while others will have to pay the cost. And that makes political decisions more difficult. Can we adapt then? I'm sure that rich countries have the money and the capacity to do so. California can easily find a way of having a good life with only half of the agriculture they're doing now. It will cost something politically, but they can do it. Copenhagen is facing a problem after 2050 with increasing sea level rise. So to protect this place from getting wet feet there, we'll have to build a defense wall around Copenhagen some way or the other. It'll be very expensive, but we can do it. And when it's necessary, I'm sure we can find the money to do it also. But poor countries and fragile states, they'll have difficulty in doing that. And I'm sure that the cost, the risk to us is not what we have to pay to protect Copenhagen from water, but it is what's coming in terms of political, economical consequences of the conditions where it's really bad, the poor countries. So the conclusions: are we running out of water? Locally, yes. Globally, no. But we'll all globally be affected by what happens locally. We are seeing that climate change is coming in as a game changer. So what used to be something in water will change due to climate change. And therefore it's so important to deal with. It's also important because local problems caused by population and bad use of water can be solved locally. But what happens with global change need a global action. I mean, we're heading towards I don't think will come that bad, 6 to 10 degrees, but and it'll not come this century. And if it comes to 6 to 10 degrees, if you don't do anything at all, this will destroy, I think, civilization or human life as we know it now. But it will not come that bad. But even global warming, somewhere between 2 and 4 degrees, which are very likely, will give major challenges for water resources and also for, as such, for conditions for human life. We can still be here, but it will be affected very much. So I think we need to act now. So with this, thank you very much for your attention.